In today's lesson, we're going to examine the idea of a confidence interval. When we do statistical studies, we gather samples, we go out and talk to some people, and we make some sort of conclusion from that. But that's only a sample. It's not everybody, so we don't know how well these samples can actually represent our populations. So the big idea today is, can we find an interval into which we can be pretty confident that the answers will actually fall? And we do this by finding something called the margin of error. Okay, so we'll look at an example here. We have a poll. It states that 80% of people are going to vote for a smoking ban, and these results are accurate to within plus or minus 4%, 19 times out of 20. What does that actually mean? Okay, what it means is that we can be 95% confident, and I'm getting that because it says 19 times out of 20. 19 divided by 20 is 95%. What can we be confident about? That between 76% and 84%, in other words, 80 plus or minus 4, actually support the ban. Now, I don't know where it falls in there exactly. Maybe 84% of people do, maybe 76% of people, maybe somewhere in the middle. But based on my sample, the small group I've talked to, I can make a pretty good conclusion about the overall population. And we call this part the plus or minus 4% your margin of error. This is my confidence level, 19 times out of 20. And this is my actual proportion of people who do something, who support the thing. We're going to use these three ideas today to create, as I said, a confidence interval. And how do we do this? Okay, so the margin of error is based on our level of confidence, that 19 out of 20 part. We call that our Z-score. And we also need to know the probability, or percent or proportion. We call that P, of course. And it goes in here. And 1 minus P, in other words, Q. So if we know the level of support, let's say it's 80%, we also know the people who don't support it, that'd be 20%, right? 1 minus P. And we kind of need to know how big our sample is. The bigger the sample, the smaller the margin of error, the more accurate our results are. But if we don't talk to very many people, our margin of error can get pretty big because, well, we don't have as much information. To find the Z-score is coming from our normal distribution. So we have three kind of common ones that we use. We have 90%, which corresponds to a Z-score of 1.645, 95, and 99. Now, I don't need you to memorize these. We're going to use them. I'll give them to you. But those are the Z-scores that come along with those levels of confidence. And that's the Z value we're going to use here in the margin of error. So how does this work? Let's take a look at an example. So in 2012, we found that 142 people out of 200 were satisfied with the job. In 2013, new survey, talked to a few more people, 160 people are satisfied with their job now. Does that mean job satisfaction is going up? It's kind of the question we'd be asking ourselves. So let's look at part A. Determine the percent of people who are satisfied with their job for each year. So let's start with 2012. How many people were satisfied? 142 out of 200, which is 71%. In 2013, we talked to we have found 160 people, but there was 220 this time, which is like 72.7%. So it looks like my job satisfaction is indeed going up. But let's find our margin of error. My error, based on the formula we looked at before, deals with my Z. My Z comes from a 90% confidence level. So go back to this table for a second here. My Z value, 90% confidence, will be 1.645 times the root of P. What's the percent of people who actually agreed with this statement? So right now we have 71% of people were confident or sort of satisfied with their job. So 1 minus P, which is Q, 0.29, and we talked to 200 people. So my margin of error, how accurate those results really were, would be 0.053. Or think of this as plus or minus 5.3%. They're accurate to within that range. Do the same thing in 2013. Okay, same number for Z. Okay, our P this time was 0.727. So we'll have 0.2773. That's Q. And this time we talked to 220 people. So over here we'll get a margin of error of 0.049. If I do it with my calculator, I do the stuff under the root sign first, then take the root of it, then multiply by 1.645. Okay, that's my confidence interval, how my margin of error. And the actual interval itself, I take the value that I thought it was, 71%, plus or minus 5.3%. It's one way of writing it. Or, if you want, you can actually do the math and say it's going to go from 67.5, that's 71 minus 5.3, up to 76.3%. That's something people support, or sorry, feel that way about their job satisfaction. Somewhere in 65 to 76%. And the same thing for the other year. We'd have 72.7 plus or minus 4.9, or if you will, 67.8 up to 77.6. That's what we call our confidence interval. Do they overlap? Well, if I look at them, yes, they do. This number is higher than this number. So there is some overlap here. Why would I ask that? Well, let's take a look at part E. Part E is, could you confidently state the job satisfaction is increasing? When we started, we said it was 71%, and then went up to 72.7%. But that was only based on the sample of people we talked to. The actual results we can be 90% confident in is they lie between these two numbers. So what could have happened here? Well, the numbers in 2012 could have actually been this high and then dropped to this. Or maybe they just stayed the same. We don't really know because there's this overlap and this margin of error. Okay, so we'd have to say a statement sort of like, since there is an overlap, job satisfaction could have stayed the same. That stayed the same. Or even dropped. It could have gone down. We just don't know. So the first calculation is based on the sample. The confidence interval tells us about the overall population to some level of confidence. Okay, and get you guys to try one. So pause the video, same kind of question, give it a try, see if you can figure out how to make this work with the information we're given. Come back to the video after and see how you did. A study of 4,000 recent graduates found that 64% found a job in their field in the first 3 years after graduating. Find our margin of error. All right, so my margin of error at 95% confidence corresponds to a Z-score of 1.96. My proportion is 0.64. So failure would be 0.36. And I talked to 4,000 people. Into my calculator, I'll get 0.015 or plus or minus 1.5%. Okay, part B, what range of percent? It can be 95% confident of, how many do we start with? 64, or plus or minus 1.5%. Or, if you want to, from 62.5 up to 65.5% of people will find jobs within the first 3 years of graduating. Okay, let's try something different. A recent survey indicated that 82% of secondary students graduate within 5 years of entering grade 9. This result is considered accurate within plus or minus 3%, 19 times out of 20. Find the sample size in this survey. So here we're kind of working backwards. I want to find n. I know the plus or minus part, 3%, and I know my confidence level. So when I'm thinking about margin of error, plus or minus 3%, well, that could be 3% either way. So how much margin of error is that? That's actually 2 times 0.03. In other words, 0.06. And the reason it's 2, it could be 3% above the actual answer or 3% below the actual answer, which is a total of 6%. So if we take our formula and we plug in the things that we know, my margin of error is 0.06. My z-score for 19 times the 20 is 95%, 1.96. My p-value is 0.82. So 1 minus p is 0.18. And I have to divide by n. I've got an equation I can solve for n. I'm going to have to do a little manipulation here. So got a couple steps we're going to follow. First thing I want to get rid of, 0.06 divided by 1.96. It's going to leave me the root stuff on this side. Right, I want to get rid of the root sign, and I do that by squaring the other side. So 0.06 over 1.96 squared. And then I have just that left. And if I want to get n, I can use the idea of cross multiplying and then dividing. Okay, so if I bring the n up here, and I can divide all of that by that number, I'm left with n equals 0.82 times 0.18, whatever that comes out to, divided by 0.06 divided by 1.96 squared. It's the same things every time. In fact, if you want a handy rearrangement, n equals p times 1 minus p divided by e over z squared. That's what that formula is. If you don't mind rearrange it, rearrange it. If you want to use the formula, use the formula. And when you type into your calculator, be careful to use brackets. You should end up with 157.5, or if you round it off because it's people, a survey talked to 158 people. Okay, so we can find a margin of error, or we can use the margin of error to find how many people we actually talked to, a survey size. Yeah, so that's our first sort of 2 ideas. I have one more idea for you. So we've been talking about the proportion of people who agree with a statement or who feel a certain way. We can also do this kind of thing with the mean. If I examine a sample and say, what was the average? Well, does that average actually fit our population? Probably not. But again, we can examine how many people we talk to and figure out a range into which the mean should fall. We call that a confidence interval for the mean. Okay, how do we do this? Well, our big idea is I take my sample mean. So when I talk to my people, what do I find for their average? I use my z-score again, how confident I want to be. And here's the one new thing. I multiply it by the standard deviation of the sample. Now, that's a little tricky, because my sample doesn't actually represent the population. So I have to find a sample standard deviation. And what I do is I take my standard deviation, sigma, and I divide it by the root of the number of people I talk to. Okay, so it's going to make the standard deviation actually change. We call it the sample standard deviation because the sample size, the bigger it is, the more accurate it gets. But if it's pretty small, it's not going to be very accurate at all. So how's that going to work? Let's take a look at an example. A study found the average time it took for a university graduate to find a job was 5.4 months, with a standard deviation of 0.8. But they only examined a sample of 30 graduates. Could we find a 99% confidence interval for how long it would actually take to find a job? So my formula is this. Okay. What was my sample mean? My sample mean was 5.4 months. That's what we found for our sample. I'm going to get a range into which it's going to fall, and I want to be 99% confident, so 2.576 would be my z-score. My standard deviation for my sample. Well, we found for our sample it was 0.8 months, but we only talked to 30 people. So that standard deviation isn't all that accurate. We're going to make our standard deviation a lot smaller. Which will give me 5.4 plus or minus 0.376. Or in other words, if I add it, I'll get 5.776, and if I subtract it, okay, it will take between 5.024 months and 5.776 months to find a job based on this sample. And that's how sample size works. Okay, so we've examined how we can create some basic ideas about how to find a confidence interval, both for a proportion, percent, and for a mean. So we have a few formulas. You need to be kind of comfortable with using your formulas. I will give them to you. You don't have to memorize them. I'll also give you your z-score table. You don't have to memorize that either. Just know how to use it. And there are a couple questions you should probably try just to make sure you can do this stuff. Nothing horribly difficult there. Be confident trying to solve for n. Okay? Be careful with your margin of error that you double it. It's always double. And if you're stuck on any of those questions, come see me.